Hello and welcome back to my channel. In my last video, I talked about what I need to build the greenhouse of this Aston Martin. And today I will be starting with the first elements. So my first element would be getting the tumble home in the side barrel. This has to be a rotational object because it has to lower itself down into the door and back up. This is possible only on constant curves or trajectories, meaning straight line or a radial line. So that means it doesn't have any changes in its curvature. This way it can slide down. So for this, I will use the model that we had from Vladimir tutorials, and in order to get this tumble home in, I would need to measure out the curvature on it. This will give us a radial point here and one here, depending on which of these cross sections I use. And then I will take the belt line here and rotate it around the axis given by those two radial measurement points. And this will help us approximate this side barrel. So let's dig in. We'll first take a simple curve. Look here for some kind of a reference in the tumble home sections. I will take this first point here, and the next one, let's say in this area here. Perfect. Now I will measure the curvature on this line here. So I will measure basically the radius of it. We'll try to do that somewhere in the middle. But it doesn't allow me to do it. So let's do a fit curve first on this section. Bring it up to that point. So we get a curve on here. Okay, let's try this. Bring this down. Bring this one further down. We can turn down the degree number of that curve I had. 5 turned on, let's take 3. We have a small deviation there. Not perfect, but you see we also get this problem here that we've got this CV right up there. Well, it should be at the bottom, so you will notice that these CV lines are crossing themselves, the hulls of the curve, so that is a no-go. Probably that's why in the shading we have this hollow looking surface, although in the cross section it seems to be positive. So I will take a duplicate curve, hopefully this one works, and it doesn't. Then if the fit curve doesn't work, the duplicate curve doesn't work, I will go into my key point curve box. So under curves, key point curves, and I will take an arc, a 3-point arc, and what I will do, I will insert 1 point on the cross section, 1 more at the middle, and 1 at the very end. This gives us a curve roughly approximating a nice constant radius along there. Now, this point here, this curve would be too short, so it will give us a highly inaccurate line. For that, I will do the same arc, but on the next cross section, which is longer, and it will allow us to have a better approximation of this curvature here. So So let's go close to the yellow edge, then in the middle, and then one towards the end here. Nice. So let's delete the guidelines. So now we have two approximated sections and one line here at the bottom. The one at the bottom is pretty flat at the moment, so we can turn it into a degree 2 curve for the very beginning. Okay, and I will use the stretch tool and one handle in the middle and pull the middle of that curve onto this section, closest one to it. This will give us a line which approximates this cycle pretty well. We can check that also by squeezing the view. This exaggerates the view we are in, and you can see we're pretty good there. Nice. Okay. And the benefits of starting off with a degree 2 curve is that all degree 2 curves are sitting on one plane, which will allow us to have one clean line there. It's not going to be S-ing for no reason. So we have the two sections approximated. We have the Beltline. Now we're just going to throw in a radial measurement on those curves, which gives us one point there, the other one there. I will bring in a curve between the 2 points, and then onto that curve I normally snap a vector, because this way our vector will have some kind of a history. So when I modify the curve, let's say if I move this CV, you see that the vector is coming with it. And now what we do is we just take that curve there, and then we will revolve it using that picked vector there, and there we have it. We have a nice rotational object there, which we know it will raise itself down and go up with no problem whatsoever. Let's extend this line, and this way we will have a surface for the complete door area. Let's extend it this way as well, and then let's turn on the sections on the surface. Also the X sections, and you will see that we are very close where the sections of the DLO are on the reference model. Let's extend this further, and there we have it. We have one belt line, and we have a tumble hole. So for the next steps in the next videos, what we will do, we will approximate the DLO curves here and then project them onto this surface, and that will give us a contour there. That contour, those surfaces that we have, we can use those to start building the A-pillar and keep going towards the middle of the car to get the greenhouse in. So stay tuned and subscribe if you haven't done that, because more will follow. Thank you.